So today we're going to talk about our Linux Efficacy project, which started in August of last year. And we'll talk about how we gathered requirements, how we gained adoption, and how we put a scorecard together. And then AB will talk about our implementation deep dive and where we're going next and some of the challenges that we expect to come. So, we kept having incidents come up, and there'd be a Linux host, and they'd be like, oh, well, what do we know about that host? And we're like, oh, we don't run tools there. And it would always come to a discussion about why don't we have the same visibility on the Windows side that we do on the Linux side, or the opposite, so that we have on the Windows side. So we decided that there were 5 areas where we really wanted to focus in order to get that visibility. So it was antivirus, next-gen malware detection, EDR, and then we have a FIM and configuration compliance program on about 35,000 Linux hosts, but we wanted to expand that. And then also later on in the project, the asset discovery team kind of wanted to partner with us so that we could give them our endpoint data as well. So we added them into our project. And so, the biggest thing when we're given this task was everyone hates agents, right? So how are we actually going to do this? The whole reason why we don't have the visibility there is because no one wants to install an agent. And so, part of it at Comcast, the culture is very much, you can plug and play and do what you want. So there's different ticketing systems for different teams. There's different monitoring. There's different builds. There's different deployment processes. And so it was really challenging for us to think about having to do this approach where we would tell all of our stakeholders across the board what they needed to do. And the other piece of it is that we have good efficacy where there's compliance requirements, right? So our PCI environments, FedRAMP, FISMA, that's the easy space for us. But in these other areas where people don't necessarily have to comply, how are we going to get them to do this? So I put together this kind of 5-year look on how we got here. So if you go back about 5 years ago, we had mature development processes. We had a standard build. Our security agents were built in where we use them for FIM and compliance. And it was pretty good, right? It took a long time to deploy a server so we could talk to application owners. And then things just started to ramp up from there, right? And we just reached a saturation point for a lot of our commercial products that they couldn't scale anymore. We couldn't keep building environments and turning up for every new application that was going up. And then eventually Comcast had a cloud-first initiative. So if you went to procurement and you were like, I need to buy a server, they'd be like, why don't you go to the cloud? So now we had even more customers going to the cloud, and the environment really changed. But then on the flip side, the environment changed for our security team too. So we moved all our logs to the cloud. We had parsed data. We could finally see a lot of our data that was usually just in a data store somewhere to meet a compliance requirement. And so now last year, people just started asking, where is the data on the Linux side? And we didn't have it. So it's kind of where how this project came about. And I wanted to talk about our scope a little bit. So we have about 150,000 Linux endpoints. We have another 150,000 Windows endpoints, including our workstations. And then there's about 40,000 hosts in the cloud. So it's a pretty big leap for us. And so we needed to find something that worked. So one of the key parts of the project was to gain adoption. And so we really wanted to get all the requirements. So we didn't want to just get the security requirements, but we wanted to get the application owners' requirements, the system admins' requirements, and really listen to everyone. And then, as we were talking to people, we really found out that things that were important to us, or we thought were important to us, weren't really important to them. So we used that feedback to create weights to our requirements to figure out what we really needed. And then lastly, we measured, so we created a scorecard, and we communicated. So we had weekly meetings, we had breakout sessions, we let anyone who wanted to participate in the proof of concepts. So it was really a collaborative effort. And then on the right there, I listed out, all the teams that we worked with. And like the threat hunters, I think ultimately were our biggest stakeholder because we wanted to get them the visibility that they needed. So finally, we come out with a bunch of requirements, right? And they pretty much fell into 3 areas. So we had our security requirements and the compliance requirements, but then we had this big group of requirements that just fell into like our DevOps, which was like how well was it going to fit into our environment. So people needed it to support multiple operating systems. We wanted it to fit into the CI/CD pipeline. They wanted self-service, the asset management piece, and then having open APIs so we could share our data, because for so long our security data was kind of kept really close to the vest, and we didn't really share a lot of that data, and we wanted to change that. And then, in order for the agent to be successful, we needed it to take up very low resources on the host. So this is the results of our scorecard. So what we did was we had 5 areas. So the compliance configuration, our FIM piece, and then defense in depth, which covered our EDR, advanced malware piece, and then interoperability, which covered how well it would work in our environment, and then our asset management side. And so what we did was we created requirements based on that, and then scored things 1 through 3, and weighted we scored things 0 through 3 and weighted them 1 through 3, so that if things were very important, they kind of got elevated up. And things that maybe were great, but we didn't really need, didn't get as high of a score. So we ended up doing a POC with 4 vendors. One was an incumbent vendor that was in our network. And so Upticks is the one that's highlighted here. So we feel like we can get great compliance configuration, the FIM piece, out of Upticks, as well as get all that EDR, the data recorder piece for our threat hunters as like a byproduct, and it's going to fit great into the environment. So this slide summarizes, where we feel that Upticks can meet all the requirements. So from the DevOps side, people are very familiar with osquery in our engineering. They're like excited about it, which is great. It's lightweight, so we're not asking for much. And it's able to cover our on-prem and our cloud solutions. It doesn't take up much resources, and we can deploy it in the cloud or internally. And we kind of get the security requirements as like a byproduct, so it's pretty nice. So AB will go over some of the technical deep dive into some of the requirements.
Thank you for my introduction, Amber. One of the other things I want to add to my introduction is that I'm a former member of the Night's Watch. I'm just kidding, it's my Game of Thrones joke. A lot has been talked about, like in this presentation, how osquery is being deployed, what's going on with osquery, what's the architecture look like, and everything else. And it's very difficult to kind of, explain further what has already been discussed yesterday. But today, I'm going to tell you guys stories. Because I think, stories help you illustrate your key points. So with every slide, I'm going to go through, I'm going to tell you guys stories about, like, how do we came to, to make a decision about a particular security control. So the first story is the CI/CD story. A couple of days ago, we were installing agents on about 400 servers. Guess what happened? The agent install failed. We were kind of trying to figure out what was going on and stuff. And it turns out that the Linux compatibility, the kernel module did not match the operating system. Well, what do we do now? Well, the thing that we came up with was that you have to do CI/CD. With CI/CD, what we want to do was, it's not that we already have CI/CD in our environment, but we wanted to kind of move towards incorporating all security tools in the CI/CD, so that way, if a developer or application owner is trying to get into installing the security agent, they can have one-stop shop, kind of get their agents from there. And also, we wanted to add unit testing to our CI/CD pipeline, so this is very important. So the story that I was talking about, why did we fail to install agent? Application owners are very strict about installing agents on their systems. they have their change management cycle, and you have to do things right the first time. And that's what security is striving for, is that we want to do things right the first time. And to do that right, we have to add a unit test to our CI/CD pipeline. And by unit test, I mean that whatever you use in your environment, if you're using Jenkins or if you're using Concourse, you can add plugins to your CI/CD. That way, you can test your agent across multiple platforms and operating systems and kernel version or what have you, and then you do the things right the first time. But with that, asset management had another requirement, and the requirement was to add software ID tags to the servers. So what software ID tags are, basically, they have a bunch of application information. What is the application version, how it's going to work and everything else. So we're like, well, while we are at it, why don't we add software ID tags in your CI/CD pipeline, so that way, when the agent is being deployed, they can have the software ID tags with it. And also, what we do is that, with agent install, we provide playbooks. So Comcast, is a big Ansible shop. So what we have is that we have a few Ansible roles defined for agent deployment as part of the CI/CD. Story number 2, and that kind of goes back to last year. So I got an email from my manager saying, oh, we got a WannaCry on our environment. And I got freaked out. I'm like, what's going on? We got hacked. It turns out that an IP address was trying to connect, internet-facing instance was trying to connect to a WannaCry IP address. And it was connected to WannaCry IP address, but it was a WannaCry IP address back in 2016, 17. And then IP has been taken out, and it was actually part of the Ubuntu NTP servers. So we're like, well, how we didn't know about it? We didn't know about it because the only information we had was a source IP address and a destination IP address, and nothing outside of it. So what we wanted to do was, for our Linux environment, we wanted to see, hey, we have source IP because, your network devices, IDSs, or network IDS, if the packets are encrypted, it's good for nothing. If you have UTM device, it will tell you source and IP source address and destination IP address. But that's all. What we wanted to see was what happened on a particular instance. So for osquery, how it's going to help us, kind of achieve that purpose is that we want to know what process was actually running. So if we knew that it was connecting on port that was not WannaCry, if we knew, if it was a process that was not WannaCry, we would not have freaked out, and we wouldn't go into all these, security incident response hoop, that we have to go to. Another interesting thing that we found during the POC was that, we were testing osquery, especially the agents provided by Optics. We tested with the security measurement tool called Veridin. So it actually measures your security effectiveness. So we installed that on the network systems, and we installed it on the endpoints. And we performed a few MITRE ATT&CK framework configurations. So we did lateral movement, we did defense evasion, and what have you. And surprisingly, the Optics console lit up. We saw all C2 communication because we had socket information. We were able to find, the change to bash history because, that configuration was part of our check, that one of the checks that we were doing and stuff. So needless to say, what we want to see is full visibility on our Linux instance, and also, we want to add security on top of it. This slide, initially when I started, it was named EDR, but I named it a data recorder, and I'll explain later, why would I remove the R piece from the EDR website. FIM. I was hearing a presentation yesterday, and there was a few critiques about FIM, how FIM has been done, and how it should be done, things like that. In Comcast, we have been doing FIM for a while. The problem we are having is that FIMS is basically based on a scheduled scan. So you run a scan, you find out, hey, there's a difference in MD5, whatever, and then you send an alert. The issue here is that the time, you do scans every night, you do scans every 4 hours. So you have that 4-hour window, or you have that 12-hour window that you have to worry about, when you're doing scans. So what Optics helps us with is basically, we were doing real-time scans on the files, that were sensitive to the environment, and as well as the file, that were provided by the compliance team. So compliance team, provides you a bunch of files, and those files, are basically, something that you have to do. Because FIM initially started as a security control, and then it was kind of like picked up by payment card industry, and it became like a compliance standard for all the networks. Also, with FIM, we wanted to kind of like sift through the logs too. So for example, like if there are changes to our file, there were like too many detections. So we want to see if a file was updated. I don't care about a few sensitive file if they were updated. Like, and then if the file was deleted or created, I want to look at those operations and stuff. So you can play around with it and kind of like make configuration based off of your need. And finally, have those detections go to our security event, incident event management. So the Splunk platform, would have HTTP events real time. So incident responder can go in and then kind of like look for detections and see, if he can perform actions on that. Raise your hands if you are part of PCI compliance. All right. That's a good number. I was kind of surprised. So payment card industry compliance actually is a compliance standard that is applicable to people who are actually collecting credit card information. You should be part of PCI. You should be PCI compliant. If you're not PCI compliant, I need to talk to you guys afterwards because. As any other company, as you guys, we also come under PCI compliance. We have other compliance. I mean, if you are hosting a federal customer, you'll have FedRAMP. If you are hosting, like a medical company or something, you come under HIPAA compliance and all these things and stuff. What we found out that compliance are actually overlapping each other. So it's basically the configuration. If you have a configuration for SSHD config or things like that, timeout, complex password, things like that are actually interchangeable across multiple compliance standards. And this is what we want to go at because our security organization gives us a standard set of standards that is more complicated and more complex than what the NIST or CIS benchmarks and all these things are. But towards the end, there are actually a bunch of configuration, system configuration that you have to do on the system. What Optics helps us with is actually, they have out-of-the-box CIS compliance. They have out-of-the-box PCI compliance. And what we have to do is just click and run a report for them and make them happy so they can put and attach that happy report to their PCI audit results saying, hey, all our systems in our company are compliant. And then also, you don't want to do like PCI compliance or the compliance on like the platform itself. So with the robust API that Optics have, you can push that data into ServiceNow. So with ServiceNow, we provide people with pretty dashboards. So we assign tags to the owners, and they can go in and then kind of find out about their instance. So how many instances they have. What is the application version of that instance. What are the RPMs installed on the systems. What is the SSHD configuration and all the good stuff on the system. So that way, you provide them self-service. That data goes into ServiceNow, and they can do their self-service over there. So how do you put that into practice? Right now we are in phase 0, so we're still like an architecture trying to figure out like what things fit what. And I'm gonna kind of go into like want versus need here as well. So our security analysts, they actually are more interested in like eyes on glass. They like 15 events or 200 or 300 events a day or something. They're not interested in all the data that we are providing them. So what do we do with them? With them, we are actually using an HTTP connector. That connector is going to go in and get the data into our SIEM. So they can get like alerts that are kind of actionable. Alerts that they can work on. Like not all raw data that they need from the platform. And then with ServiceNow, make our asset management team happy and stuff. We have an API and it's an API endpoint that have all the asset information in it. We'll get the data into ServiceNow through an API as well. But what do we do with the rest of the data? The rest of the data is going to go into the Kafka cluster. So on the Kafka itself, we are either going to use the org file that's going to go directly into S3, or we are probably going to use like a FileBeat, that's going to pick up the files from the Optics platform and then push that into a Kafka. And then from Kafka, that data actually goes into a data lake, which we in our company use S3 for I think we have about like half a petabyte data right now that goes into S3. And when the data is in S3, you can perform multiple things with it. Like, you can do machine learning. You can put it in Event Data Warehouse. You can put it in Databricks. You can put that in Athena and then run your business intelligence and Tableau queries and stuff like that. And most of all, we want to provide role-based access control, or DevOps. So one of the things, while I was doing POC, an admin asked me, he was just like, hey man, like, installing a security agent, but what is in there for me? Like, why would I need to install a security agent on a system? So I'm like, hey, it's not like that. We are providing you guys self-service and API, so you can kind of go back and query your fleet. And that way, when you're, when you have a problem in your environment. So, Comcast is very like DevOpsy culture. So we have a lot of infrastructure as a service. We have a lot of like CloudFormation, Terraformation, things like that. And what happens is that, when you are deploying so many things on the fly and destroying so many things on the fly, you need to know who did what at point in time. So that way, people who are actually owning a few assets, we have that information, and we can go back in point in time and find out like who actually spun up like 1,000 servers at night and actually spun it down, and what were things that happened on the server. And the forensics-wise too, like if there's a if there's like a process somebody ran and did something to it, you'll be able to find that in your historical data recorder. So all this looks very nice in the picture and looks very good. But there are challenges that we think might come as part of the implementation. One of the challenges is basically removing noise and false positive. And by that I mean that when we initially started our testing, we were getting so many detections that it would kind of like spin our head, for us as an admin, us as an implementers and stuff. And then when we found out that, hey, every night, we have a nightly scan that runs, the Qualys scans, and it's a lot of false positive. How do we remove that? There's a lot of file integrity monitoring events that are happening. How do we remove that? Things like that. So with that, what we are planning to do is to refine our queries to a sense that they could whitelist the Qualys IP addresses and stuff, and then you can get all the defined data that we can. Because like half the detection in your environment is probably through a security scan, and you want to reduce that. Managing large amounts of data. So I think per server, we are anticipating about 120 megabytes a day, and that's a lot of data. So thankfully, our platforms like Kafka, are strong enough to kind of handle that kind of load, and then S3 basically charges you on the read and not on the write. So we are good on that end, and we can kind of manage that through that. Streaming versus polling. So I think that's like the biggest critique of osquery is that, hey, you are actually collecting data at a point in time. You are actually doing queries and stuff. And how about if an event happens, a cron job happens in a time frame when you are actually doing your collection in a 5-minute time frame or 3-minute time frame? What is the difference? Part of the POC, we were testing another tool was Sysdig. So Sysdig is basically, I would call it like a rival of osquery. With Sysdig, the problem we were having was that Sysdig was very focused on like container platform, and as well as the problem with Sysdig was that you again were like you wanted these kernel modules to be installed on the system. Then again create the problem like how does it mess up with the kernels? Would you have a compatibility next time Red Hat 8 is out? Would they have like kernel modules available for Red Hat 8, like on day one, things like that? Because most of the security tools that I've known, still do not have support for Red Hat 8 as of January. So it takes time for them to do the support and stuff. So I think you have to like do a balancing act that Erin talked about when you are choosing your agent. Lack of control in agent validation is another one. So the control is basically this. You're installing a security agent and expecting the logs to be coming in continuously. But what about if somebody stopped the service? You would not have any validation against that. What about like if the flags were somehow changed? What about like the influx of data? So for that, I think the idea is to create like a canary node and then kind of have a Grafana charts against it to see, what would my golden image send as logs versus, the instance that I've installed everywhere else to see the amount of logs and compare them to each other. Actionable alerts is another one. So when I was talking about the data recording piece, the problem we have is that, yes, you have all this good data, you have all this detection, we were able to find C2 communications and stuff, we were able to find via third party, we were able to find configuration changes and everything else. We were able to find that, somebody ran a credential escalation. We were able to find, somebody ran actually removed the bash history and then did a backup or things like that. All these things were part of the detection that we were able to find out. But what was the remediation techniques? And we had nothing. So for that, I think we are actually pushing optics to kind of create us like a remediation, or maybe we can just push a firewall policy on an instance and then make sure that that instance is basically contained to an extent that we can kind of pull that data back or work on that and then give it back to the customer. And last but not the least, SQL is not everybody's cup of tea. In Comcast, we have worked on big data for a while. We have written a lot of Presto. For a couple of years. So Presto and Athena and big data and everything else, that's something that we have done over the years. But for incident responder, for a person, who just wants to have a few reporting run, like a compliance engineer, it's not their cup of tea. So I think what would happen is that, we probably have to kind of assist them in the meantime, to run their reporting and stuff, or, actually give them some kind of education on how to write simple SQL queries to get their information out of it. What are our 2020 goals and stuff? So currently, as I said, we are in phase 0. So we are finalizing architecture. The MSA is being signed. We are actually talking to people, and then we're trying to do the business adoption in the middle. So we would have a staging environment. Have a few customers. Talk in the company, talk to us, and then have them install the agent on them to see what is the performance impact and everything else. And then phase 3 and phase 4 is going to be basically doing file integrity monitoring and configuration compliance, and then have that data basically back into Splunk and ServiceNow and big data to do all that good stuff that I talked about in the slide. All right, thank you guys.
Thank you.
Appreciate it. Yeah.